How do you factor perfect square trinomials? These are the examples starting page 16 in your booklet. So trinomial means I have three terms. Let's look at the question number 12 in your booklet. So b squared minus ab plus 16. So I have 1, 2, 3 terms. Now I would like you to always approach factoring the same way. Always look first. Is there a GCF? Can I apply GCF in this case? So look at the three terms. Do they have something in common? These two have b in common. These two have 8 in common, but there is nothing that they all share. So no. What about the difference of squares? Are there two terms? Something squared minus something other squared? When you look at the terms, no, it doesn't fit. So I have three. That's why I'm calling the trinomials. Now, why do I call them perfect square? You will see in a second. So the easiest way to factor a trinomial, if you are lucky, is to have something that is expression, for example, x squared plus 4x plus 4. This would be ideal, wouldn't it? It would be so easy if the factors are exactly the same. So when I have two factors that are exactly the same and then I can rewrite them like that, I call this a perfect square. So is this trinomial, are you that lucky that you have a trinomial that you can write as a perfect square? There is a way to find out. So this is how you will check. First, you will look at your first term. Is it a square of something? Yes, it's a square of b. What about 16? Is this a square of some number? It is. It's square of 4. Now, the middle term, is it 2 times multiplied these two factors? Is this equal to 2 times b times 4? This is ab. Yes, it is. If that's the case, you will copy this sign, and this is your factored version. We will do one more, don't worry. So the trick is, again, to check for your trinomial. Does it satisfy these silly conditions? So let's try another one. Question 14, for example. M squared minus 10m plus 25. Again, always, first, is there GCF? Because sometimes you will have more ways of factoring. Is there GCF here? No. Do I have here two terms that I can apply difference of squares? No, not really. I have three. So let me check if this is actually difference of squares. So I'm going to check, is this a square of certain number? Yes, of m. What about 25? Is this some number squared? Yes, it's 5 squared. Now the middle term, is it exactly the same as m times 5 times 2? So m times 5 times 2, it is. So m times 5 times 2, that is 10m. It fits. So remember to copy this sign here, m minus 5. So my expression is m minus 5 squared. If you don't believe me, let's check. What is m minus 5 squared expanded equal to? So this is m minus 5 times m minus 5. Let's multiply everything. M squared minus 5m minus 5m plus 25. So this is equal to m squared minus 10m plus 25. You can always check this way. If you multiply your factored expression, are you going to go back to the beginning? So now you know three ways of factoring. First one is GCF. Second one is difference of squares. That's equal to a minus b, a plus b. And the third one is perfect square trinomials, a minus b squared is equal a squared minus 2ab plus b squared. Now you can do all your questions until page 17.